You ever click send on an email or upload a photo and just wonder? I mean, how does it get there? It feels instantaneous, right? But what's really happening in that split second? Is this incredible hidden journey? Your data is literally flying across the globe. So, today, let's pull back the curtain and actually follow that message step by step. So, it all starts with just one click, one tap, that send button. Seems so small, so insignificant, but that one action, it's the trigger for this massive, super fast chain reaction that basically runs our entire digital world. And that's the big question we're tackling. What is that journey? We're going to follow a single message from the second it leaves your screen as it dives into the wild maze of the internet, all the way until it pops up on someone else's device. I mean, this happens billions of times a day, and we never even think about it. Okay, first things first. When I say message, what am I talking about? Well, it's pretty much anything. It's the words in your email, yeah, but it's also that photo you're posting, the numbers in a report, or even the show you're streaming. It's all just data. And all that data has to travel from point A to point B. Now, before your message can hit the digital highway, it's got to be prepped. You can't just toss a huge video file onto the internet and hope for the best. Nope, it has to be packaged up just right for the trip ahead. And this is where it starts to get really, really clever. The secret sauce to this whole operation is something called a protocol. The best way to think about a protocol is like a rule book for the internet. It's a set of instructions that every single device agrees on. It's how your phone in New York and a server in Singapore can talk to each other perfectly. Without these rules, it would just be total chaos. The whole thing kicks off right inside the app you're using, your email, your browser, whatever. To make this all work, your device uses what's called a layered model. Think of it like a little assembly line. The very first layer, the application layer, just gets the data you made and passes it down to the next station to get it ready to ship out. Okay, this is where it gets really cool. Your device doesn't send your message as one giant piece. That would be way too slow and clunky. Instead, the next station on the line, the transport layer, acts kind of like a paper shutter. It chops your big message into tiny little chunks called packets. And here's the genius part. It slaps a number on each one, like page numbers. This is going to be super important later, you'll see. All right, so now we have all these little numbered packets, but how do they know where to go? For that, we move down the assembly line to the next layer, which basically acts like a massive worldwide postal service. This comparison nails it. You know how a physical letter needs a street address and a zip code? Well, every single one of our data packets needs a digital address. We call it an IP address, and the network layer's job is to stamp each packet with the IP address of where it's coming from and where it's going. That string of numbers is its map for the entire journey. So who are the mail carriers in the system? They're these devices called routers. They are everywhere online, and their job is simple. They look at the destination IP address on every packet that flies by, and in a split second, they decide the best way to send it along to get it one step closer to where it needs to go. Okay, quick recap. Our message is chopped up, it's numbered, and it's addressed. It's almost ready to go. There's just one last thing to do before it leaves your device. We have to turn all that digital information into something physical that can actually travel. So, just before it makes the leap, the data link layer wraps each packet in something called a frame. The best analogy is putting our already addressed letter, the packet, into a specific mail bag that's only going to the very next stop, like your home's Wi-Fi router. It's for a super short local trip. And finally, we hit the physical layer. This is where the digital becomes real. Those ones and zeros in the frame get turned into an actual physical signal. Maybe an electrical pulse zipping through a copper wire, a flash of light shooting down a fiber optic cable, or a radio wave beaming out of your phone. The message is officially on its way. So our little packets have traveled across cities, maybe even oceans, as tiny signals of light or electricity. And now they're arriving at their destination. But the job isn't over. The entire process we just saw now has to happen in reverse. It's time to put the puzzle back together. As the packets start showing up, the signals are turned back into digital bits. But here's the wild part. They almost never arrive in order. Packet 3 might get there before packet 1. And that's not a mistake, it's actually a feature. The internet sends each packet on whatever path is fastest at that exact moment, dodging traffic jams. It's built for speed, not for standing in a neat line. So, how do we fix the mess? Well, remember those sequence numbers from the very beginning? This is their moment to shine. The transport layer on the receiving computer looks at the number on each packet
And, like a puzzle master, puts them all back in the right order. 1, 2, 3. It recreates your original message perfectly. It even checks if any are missing or broken and asks for them to be sent again. Pretty smart, huh?
And that's it. From your single click to a perfectly reassembled message on another screen, that entire journey, the chopping, addressing, transmitting, and rebuilding, all of it happens in less time than it takes you to blink. It really gives you an appreciation for this gigantic, invisible machine that's always working for us. And the speed is just mind-blowing. Look at this number, 10 gigabits per second. That's the speed some local networks can hit now. We're talking about billions of bits of information being moved and sorted every single second. It's just an astonishing piece of engineering that makes it all feel instant. Think about it. From a simple email to streaming entire virtual realities, this basic process is what makes it all possible. This invisible system of rules and packets is what connects billions of us across the globe. It really makes you wonder, what kind of journeys will our messages be taking next?